Hello, everyone. So I'm coming back today to talk about elementary matrices. So basically, I will show an example, on how to write a given matrix as a product of elementary matrices. All right. So here first we have what is an elementary matrix? So it is any matrix that we can get from the identity by a single row operation. So for instance, this is, my identity size 21001, right? So if I do, I'm sorry, 1001 right here. If I do um, 1/2 of R1, so I get 1/2 001 single row operation. That is an elementary matrix. Okay. If I do if I do -2 R1 plus R2, I replace it with R2. So I have 1, 0, and here -2, and here 1. This is an elementary matrix, right? So we're going to give a random example of a 2 by 2 matrix that we're going to try to write as a product of elementary matrices. But first, let's see this. If I have my matrix A is 1, 2, -1, 3, right? So if I do this, single row, this is identity right here, 1, 0, 0, 1, right? Identity size 2. If I do a single row operation here, for instance, I do 1, 2, and here I do R1 plus R2. I replace it with I2, it's going to be 0 here and here 5. If I do the same one on the identity, if I do the same R1 plus R2, which is 1, 0, and here 1, 1, you see this matrix, elementary matrix E. If I call this matrix B, for instance, the one I got, so when you multiply E by A, to the left of A, we put E times A. To the left of A, not the right, to the left of A. Let's see what you get. We have 1, 0, 1, 1 times A, which is 1, 2, -1, 3. Let's see what matrix we're going to get. If we do the product quickly, we have 1 here. 1 minus 1 is 0. 2, right? And here 2 plus is 5. We get exactly B. You see? So, which means if you do a row operation on a matrix A, you get another matrix B. You can obtain that matrix B by multiplying A with an elementary matrix that you did the same row operation on the identity. All right? And we're going to use that to do what you want. So now, for instance, if on your test you have write the matrix A equal 1, 2, 3, 4 as a product of elementary matrices. First and foremost, we must say the result, it might not be like a unique way to do it. It might not be a unique way to do it. Since this one is a 2 by 2 matrix, so we're going to try to do, the way we think is easiest for you guys. So write A here, which is 1, 2, 3, 4, right? Right here is identity size 2. which is 1001. And then let's see. So basically, since I want to write A as a product of the elementary matrices, so let me do some row manipulations on the A, and then I'm going to do the same row manipulations, row operations on the identity. For instance, so basically I'm trying to go from here all the way to go to get the identity. I try to, just like we do Gauss, I try to go from here, do some row manipulations to get the identity on A. And then I see in each step how to write. So we have what? We have, of course, here, let's do this row manipulation, 1, 2, and here we get to do -3 R1 plus R2. So what you get? We get 0 here, and here -2. 2 times -3 is -6, plus 4 is -2. We repeat the same thing here on the identity. So we have 1, 0, and here -3 R1 plus R2. So what do we get? We get -3 and here 1. This one is my first elementary matrix E1. What we said here is when you multiply E1, if you do E1 times A, we get what? We get this one right here. You see, E1 times A is this matrix right here. All right, let's keep going. So we have, now I'm going to make this one 1 here. So I have 1, 2, and here -1/2 of R2. Of course, I will get 0, 1 here. So now I have to do the same row operation, but on what matrix? Not on the E1. No. We're going to do the same one on the identity. We're going to do the same one on the identity. Every step, every row operation we do on the matrix on the left, we have to do the same one on the identity, on the original. You don't do it on the E1. Please avoid that mistake. You don't do it on the E1. You do it on the identity. So what I get 1, 0, 0, -1/2. This is E2. So basically what we're saying here is, again, when you multiply E2, if you do E2 times this matrix right here, let's call this one is B. B, so E2 times B will give you this one, C, right? Which means so far what we have E2, B itself is what? B is this, times E1A is equal to what? Is equal to C. All right, so, we could stop here and solve for A, right? We could stop here, solve for A, but it's easier to do one more step. So it's easier to go until we get the identity. Let's pursue here. So we get what? We get, now let's do -2 R2 plus R1. What you get? We get 1, 0, 0, 1, right? You see, that's the identity, size 2. And let's do the same, -2 R2 plus R1, but let's do it on the identity, what you get on the identity, remember. So let me write the identity here so I can see it. Let me do the same stuff on here. So -2 R2 plus R1 will be 1 here, 1 here. That's going to be -2, 0, 1. Remember, everything we do it on the identity. All this stuff right here on the right side, we do them on the identity. We don't do them on the elementary matrix above. We do them on the identity. Please avoid that mistake. Okay? So what we get? So this is E3 right here. So now E3 multiplied by C E3 multiplied by C is give me what? It's give me I2, which means E3 times E2 times E1 times A is equal to I2. So now I solve for A. If I do the inverse of everybody here, right? So I get A equal to E1 minus 1, E2 minus 1, E3 minus 1. So basically, if I multiply the inverses of each elementary matrix, I get A. So now I just need to find them. So what is E1 minus 1? So E1 is, let me scroll up, 1 negative 301 rapidly. So E1 minus 1 will be, since the determinant is 1, so 1, 1 here, 3, 0. E2 is 1, 0, 0, negative 1 half. So E2 will be, the determinant is negative 1 half. So 1 over negative 1 half, which is negative 2, times negative 1 half, 1, 0, 0, which is 1, 0, 0, negative 2. All right, that's E2 minus 1. And finally, E3 is 1, 0, negative 2, 1. That's E3. So E3 minus 1. The inverse, here the determinant is 1, so it's going to be 1, 1, 0, 2. So when you multiply them, when you do E1 minus 1, which is 1, 3, 0, 1, multiplied by E2 minus 1, which is 1, 0, 0, negative 2, multiplied by E3 minus 1, 1, 2, 0, 1, you should get A. 1, 2, 3, 4. Right? If no mistake on our parts, that should be it. Again, it's not one way. You know, basically you can stop. If you get like 2 elementary matrices, you can stop there. But then, you know, you have to find the inverse of the other one, you know. But if you go all the way to the identity, everybody knows the inverse of the identity is the identity itself. All right, so this was just an example on how to write a given matrix, you know, as a product of elementary matrices. So here, to arrive to the identity from A, we kind of did 3 steps. And each steps we have one elementary matrix, that's why we have 3 of them. And on your test, don't stop, you know, by saying E1 minus 1, E2 minus 1, E3 minus 1, without writing them explicitly. You need to write explicitly the inverses. If you don't write explicitly the inverses, something is missing. All right. Thank you very much.